There are moments in human history that seem to transcend time, borders, and even reason itself. Moments that make us acutely aware of how small we are and how far our ambition can reach. One such moment occurred in 1977 when two fragile machines, Voyager 1 and Voyager 2, roughly the size of a small car, were launched into the vast emptiness of space. They carried computers less powerful than the average car key today, and their initial mission seemed modest. 5 years of exploration and data collection from Jupiter and Saturn. Yet, what followed was nothing short of extraordinary. Against all odds, these spacecraft not only survived but surpassed every expectation, venturing far beyond their intended mission parameters and fundamentally rewriting humanity's understanding of the cosmos. Decades later, nearly 24 billion kilometers from Earth, Voyager 1, the most distant human-made object in existence, transmitted a signal that confounded every expectation. Its orientation, readings appeared nonsensical. Telemetry, data seemed corrupted. Yet its signal arrived consistently, as if it were whispering from the depths of the void. The anomaly was puzzling. How could Voyager 1 maintain such a strong, clear signal when its internal systems seemed to be sending gibberish? Was it merely a technical glitch? Or was it encountering something in deep space that challenged everything engineers and scientists understood? In an era where technology becomes obsolete within mere years, the continued operation of Voyager 1 feels almost surreal. The spacecraft built with 1970s technology carried memory and computing power laughably small by today's standards. Its 8-track magnetic tape storage and central computer were dwarfed by the devices we carry in our pockets and even by the control systems of a microwave oven. Yet, for more than 45 years, Voyager 1 has journeyed further than any other human-made object, traversing beyond Neptune, beyond the Sun's protective magnetic envelope, into the infinite darkness of interstellar space. This longevity was no accident. It was the result of meticulous inspired engineering. Voyager 1 was constructed with triple redundant systems, backup thrusters, auxiliary heaters, and a nuclear power source made from plutonium-238, designed to decay slowly and supply electrical power for decades. NASA engineers anticipated failures and designed the spacecraft to endure them, ensuring that even as components failed, Voyager could continue its mission. Yet, now, for the first time in decades, the spacecraft appeared confused. Attitude and Articulation Control System, ACS, the part responsible for determining its orientation and ensuring that its antenna remained pointed toward Earth, began transmitting data that was incomprehensible, numbers that defied physical possibility. Paradoxically, despite these nonsensical readings, the signal itself remained strong, arriving with clarity, as if Voyager 1 were saying, "I am here, but I am experiencing something beyond your comprehension." The anomaly initially manifested subtly. NASA engineers noticed that the ACS readings no longer matched reality. The spacecraft appeared to claim it was pointing away from Earth, which under normal circumstances would mean the signal should be lost. But Voyager 1's signal persisted, clear and steady, prompting questions and concern. Engineers wondered if the data was corrupted, if Voyager had switched to an old or backup computer, or if it had encountered an environmental factor in interstellar space that had never been modeled. Teams scrutinized every subsystem, finding that most remained stable and that the scientific Instruments continued to return coherent readings. Power levels, though diminished, were still within operational limits. Remarkably, the antenna, a 3M dish drifting in the void, somehow remained aimed directly at Earth, transmitting intact scientific data. It was as if Voyager's cognitive system had fractured while its physical systems carried on, a ghost in the machine persisting against impossible odds. NASA faced a harrowing reality. Voyager 1 did not recognize that anything was wrong. It had not entered safe mode or issued any alarms, meaning that whatever caused the anomaly was occurring in a manner that defied conventional understanding, with the probe continuing to transmit with unwavering confidence across billions of kilometers of emptiness. The engineering teams worked tirelessly for months, sending carefully calculated commands, running simulations, and digging through decades-old documentation written by engineers who had long since retired. Every interaction required extreme precision because a signal takes approximately 22 hours to reach Voyager 1 and another 22 hours to return, making even a simple question and answer exchange nearly 2 full days long. Theories about the anomaly ranged from radiation-induced damage to a corrupted subsystem transmitting false ACS data. Some speculated poetically about magnetic distortions, gravitational anomalies, or unknown patches of interstellar space with unpredictable behavior. Ultimately, the cause was identified. Voyager 1 had switched to an old damaged computer system to transmit orientation data, a system not used for decades and not intended to function. This switch corrupted the orientation readings, creating the illusion of incomprehensible data. The remedy involved instructing Voyager to return to the primary functional computer system, a delicate operation given the spacecraft's autonomous logic and immense distance. Once successfully commanded, Voyager 1 slowly resumed coherent transmissions. The ghost and the machine seemingly silenced. Yet the reasons behind its switch to the dormant system remain a mystery. Was it a random computational fluke or a subtle response to the uncharted conditions of interstellar space? Voyager 1's journey through space is far from simple. The probe navigates the interstellar medium, a chaotic environment composed of magnetic fields, cosmic radiation, and remnants of ancient stars. Even after crossing the heliopause in 2012, officially entering interstellar space, Voyager detected unexpected phenomena, including an 80-fold increase in plasma density, yet with no corresponding change in magnetic orientation. This was the opposite of theoretical predictions, and suggested that interstellar space exhibits behaviors and boundaries not fully captured by existing models. As Voyager continues its journey, engineers and scientists ponder whether previous anomalies, including the ACS glitch, might indicate interactions with unknown forces, subtle signals revealing the complexity of the environment far beyond our solar system. Every fluctuation, every unexplained reading challenges our understanding of physics and of space itself. After resolving the ACS anomaly, NASA experienced a brief period of relief, but it was short-lived. Soon, another critical subsystem, the Flight Data Subsystem, FDS, responsible for collecting and transmitting both scientific and engineering data, began to fail. The FDS is essential. Without it, Voyager would be unable to observe, record, or communicate the cosmic environment. In late 2023, the data stream from the FDS degraded, transitioning to a form of static not seen before, an empty signal suggesting that Voyager had effectively forgotten how to transmit. NASA engineers spent months methodically sending diagnostic commands, examining deep logs, and hunting for the elusive signal that could restore functionality. Voyager 1's saga is a testament to human ingenuity, perseverance, and curiosity. Built with technology that now seems archaic, it continues to push the limits of exploration, operating in conditions that are impossible to replicate on Earth. It has revealed a universe far stranger than anyone imagined. From Jupiter's turbulent storms to Saturn's rings, from the edge of the heliosphere to the chaotic turbulence of interstellar space, its intermittent anomalies, glitches, and the challenges faced in maintaining communication underscore the unpredictable nature of deep space exploration. These events remind us that our models, though sophisticated, are still incomplete, and that the cosmos contains phenomena we have yet to understand. As Voyager 1 drifts farther into the black turbulent sea of interstellar space, it carries with it the legacy of decades of human ingenuity and the quiet promise that, even in the darkest reaches of the universe, humanity's voice, though fragile, continues to reach outward, listening, observing, and daring to understand the impossible. Each strange reading, every restored subsystem, every patient command issued by engineers on Earth tells a story of resilience, curiosity, and discovery, demonstrating that even a machine built in the 1970s can continue to surprise and challenge our understanding of the universe. Voyager 1 is more than a spacecraft. It is a bridge between human ambition and the vast, unknowable cosmos, a reminder that even the smallest creation can reach the farthest corners of existence, leaving whispers of humanity in the void, encouraging us to continue exploring, questioning, and marveling at the grandeur and mystery of the universe that surrounds us. This is the story of Voyager 1, a story of unexpected glitches, miraculous engineering, and the relentless pursuit of knowledge in an environment that defies comprehension. It is a narrative of survival against astronomical odds, of signals that speak across billions of kilometers, and of the ever-present uncertainty at the edge of what we know. Its journey teaches us about resilience and ingenuity, about the limitations of our understanding, and about the tantalizing mysteries that lie just beyond our reach. Voyager 1, despite its age and the frailty of its technology, continues to venture where no human has been, encountering phenomena that challenge our understanding of physics and engineering, all while maintaining its voice across the void. Every signal it sends is a testament to the brilliance of the engineers who built it, the dedication of the scientists who maintain it, and the enduring human spirit that drives exploration. In the end, Voyager 1 is more than a probe. It is a symbol of humanity's audacity to reach beyond its confines, to explore the unknown, and to leave a trace of itself in the vast silent expanse of space, proving that curiosity and ingenuity can transcend time, technology, and even the boundaries of the solar system itself. It stands as a reminder that the universe is far stranger and more complex than our models predict, that anomalies are opportunities for discovery, and that, even in isolation, far from the sun and all familiar influences, human ingenuity can persist. Voyager 1 continues to drift onward, carrying its instruments, its nuclear heart, and the whispers of Earth across the dark. Its journey challenges us to think bigger, to dream further, and to marvel at the audacity of sending a small machine into the void, knowing it might never return, yet hoping it will endure, observe, and communicate. It reminds us that the edge of our knowledge is not a boundary, but an invitation, a call to observe, question, and learn from the cosmos itself. Every anomaly, every signal that seems impossible is part of a narrative larger than any single human life. Narrative that binds the ingenuity of one generation with the curiosity of the next. Voyager 1's journey continues to teach us humility, resilience, and the unending pursuit of knowledge, inspiring future generations to reach farther, explore deeper, and always listen carefully to the whispers of the universe. Through glitches, repairs, and decades of operation,